Hello everyone. If you are into electronics manufacturing services like EMS, if you are doing any OEM, if you are into electronics production or you are a new product design and developer, then this video is for you. Please don't scroll, watch full video. You will get lots of knowledge in this video. So when you are doing any electronics productions, what is the biggest issue you are facing? That is testing. And what kind of testings you are doing when your final PCBA or final product is ready. So lots of suppliers, what they are doing right now is they are some of the engineers are sitting and doing a testing on PCBs like for voltage, current, PWM, duty cycles. They are manually taking PCBs and testing that PCB is giving perfect voltage or not, perfect output is coming or not. So indeed, that case, there is the biggest five major problems rise. One is accuracy, accurately they are measuring or not. Second is productivity, proper productivity they are giving or not. Like safety is also more concern. Like you are working with the single phase or three phase PCBs, then safety is biggest concern. Costing is a next concern, that how much time they are going to take to test one PCB. And data management, how you are managing data, how many PCBs are tested and what test results are coming or not. So this kind of lots of issues are coming in testing for the production. When you are doing a production, like you are doing a production of 500, 5,000 or 50,000 pieces of this type of PCBs, and if you want to test it out that this PCB is functionally working perfectly or not, then this kind of equipments are very useful. Hello guys, this is Mayank Chawda from Team Micro, and we are focused on to test automations, and we are providing the customized PCB test solutions, and we are providing the test automation solutions to lots of different types of clients, and we are working with lots of EMS as well as product developers. So let's start today's video, and let's give you the brief example of this particular system. This is very economic system, and this is very cost effective for the production, and this is going to save lots of time when you are doing production of electronics. Let's take one example, this particular PCB. If you have this PCB, this is a very tiny PCB, you can see. Oh sorry, this is a very tiny PCB, right? So if you want to test this PCB, one first is flashing of this type of PCB, how you are going to program this PCB when microcontrollers are there. So it will take lots of time. Second, you want to test some of the voltages are coming or not, how you are going to check it out these voltages are coming or not. Third major point, like this type of small push buttons are there. If you want to test these push buttons are working or not, so you can see a tiny push button. So when these PCBs are programmed flash, some voltage are coming, I want to check it out. So it is not feasible to test perfectly even in big PCBs. Even if this kind of PCBs, if you want this kind of type of things, then it will take a lots of time. So according to you, how much time it will take? So please comment what kind of time your person is taking to test this type of PCBs. And now, if you introduce a simple fixture where pop-up structures are there and you can easily access the points, then make things is going to be easy. So it will take approximate minimum 10 to 12 minutes when this kind of PCBs are there. One is flashing, one is voltage testing, and third is the push button testing. So it will take lots of time. This is particular 4 cavity fixture. So you can see at a time 4 PCBs we can put here. When we put the PCBs, you can see a pop-up structures we have provided. So these are plunger type of pins. This is test pins, uh, and this is ESD safe material. Also, when you are testing this kind of PCB, and when you are touching with the fingers, then ESD safe systems is required. So when manually you are doing that, it is not going to be possible. Using this type of fixture, it is possible to test this PCB into ESD environment. So you can see a test points available here, TP points. If TP points are available, we can directly take the points from there. If TP points are not available, we can take it from the DIP component legs. Also, it is also not available, we can take some of the points from the SMD component legs. So yeah, you can just share your PCB image or Gerber file or some of the data. We can get back to you with the solution how we can provide this particular test automations to you. So what user needs to do, user just need to, you can see a cavity, we have provided cavity here. So mechanically it is going to go into one direction. This PCB can go into one direction only. You cannot put these kind of PCBs in another other direction. Just need to put it out these PCBs here. Yeah. Okay. Uh, it is not placed properly. You can see it is placed properly. As in other conditions, I cannot place this PCBs. It's perfectly aligned system. Also, in all the videos, I always talk about the mechanical structures what we are providing here. Here pogo pin structures are there. There's a guide pin with the cavity. These are the plungers for the pressing of the PCB. So we are also taking care when PCB you are pressing, it is not going to bend or it is not going to damage any components. Just what user need to do, just need to toggle this clamp like this, and you can see a connectivity of all the pogo pins will come to the connector. I'll also open the structure. See, you can, we will take this kind of connector here, and from this connector our electronics measurement system will be there. It is directly going to give you the output that this voltage is coming or not, this particular data is coming or not. Even if you have placed 4 PCB 1 2 3 4 what 1 2 3 4 PCBs data are coming or not. And one more major thing, the push button. So it's a small tiny push button you can see here. When I'm pressing this plunger, this is a spring loaded plunger here. So it is going to test the button is working or not. Also we take care when you are pressing full plunger, it will not damage the push button because the hardly 1 mm or 0.5 mm displacement of the push button is there. So it is not going to damage the push button or not. So we are taking lots of mechanical accuracy here. We have in-house mechanical tool room and we have in-house machine setup. So we are managing lots of micron level accuracy here. Also, we are in-house electrical, electronics, and software development team. So they are sitting on a single table and providing the best out test solutions for your PCBs. So you can see when I'm going to press the plunger, it is going to push the pr- push button, right? So this kind of structure we are providing for the lots of PCBs. So if you have any such kind of requirements, you can contact Micro. We are always providing best out of the best solutions to our clients. And thank you guys for giving lots of orders from YouTube. Please like, share, and subscribe our channel. And please press bell icon so we will get the notifications from Micro and you will get new videos and new updates from Micro. Thank you guys for watching.